In this video, I will provide a brief introduction about three-dimensional printing, also known as 3D printing. By the end of this presentation, you'll be able to tell me how 3D printers work. You'll be able to describe the importance and potential of 3D printing, particularly for the field of rehabilitation. And you'll also be able to describe some 3D printing materials, including filament, which is what we print with, the printer itself, and the objects that we print. So let's begin by talking about what is 3D printing and how does it work. So 3D printers create a solid three-dimensional object out of a variety of materials. On the left, you can see a 3D printer printing in concrete. This type of printer might be used for a construction project or in a school of architecture, so they could just directly print the house using a very large 3D printer that's printing in concrete. On the right, you see a 3D printer creating a clothing item, and it is printing in yarn. So both of these are 3D printers, but they're printing in different materials. Most often when we talk about 3D printing, we print in plastics, and I'll talk to you a little bit more about the different types of filament later, but just know that you could print in any type of material as long as it's compatible with your printer. So 3D printing comes out of a long history of a technology called additive manufacturing. So 3D printing is a form of additive manufacturing, but not all additive manufacturing processes use 3D printers. So as you can see in this video, the 3D printer is creating a pumpkin. It starts at the bottom layer of the pumpkin, it prints the bottom layer, and then the next layer, and then the next layer, and so on and so forth until the entire pumpkin is printed. So it is adding a layer to manufacture this pumpkin, and it goes from the bottom up. So that is why it's called additive manufacturing. So as you can see, there is this pink filament. So this is a thermoplastic. It goes into the print head, it gets heated up, and is extruded layer by layer. So think of it as a very fancy hot glue gun. So you have your plastic, it goes through the machine, it gets heated up and extruded. But instead of you controlling where the plastic goes with your hand, as you might with a craft project, the computer controls where the plastic goes, and it's able to be more precise so that it could create a specific object. And on the right, you can see the rose that was printed by the 3D printer. And if you look closely, you can see the lines, and each of those lines represent a different layer that was done by the 3D printer. So it printed it very slowly from the bottom up, layer by layer, until it completed the rose. So that's how 3D printing works in a nutshell. 3D printers have the basic parts are the same, but different printers may have different components. So in every printer, you'll see an on and off switch. So this is the printer that I have in my laboratory. It's called a Lulzbot Mini. And so here's the on and off switch. That's how you turn the device on and off. The object, the 3D printed object, is printed onto the print bed. So the print bed is this piece right here. It does get warm. I believe typically it gets to about 60 degrees, and that's because as the plastic is heated up and goes through the head, we want it to be printed onto a warm surface so there's not that huge temperature differential that might make the plastic warp. This is right here is it's the hot end, so that is where the plastic is melted and comes out. These is the tool head and the rod, and so these move around to make sure that the plastic comes out where it's supposed to. So this moves up and down and left and right, so it could print, and then the print in this specific printer, the print bed moves top to bottom. So that way the print head can happen in the XY, it can move in the X, Y, and Z range. And then at the very top, you see this is where you put your filament. So filament is often sold in a spool. So you put your spool of filament here, and then you thread the plastic down. So those are the major components of the 3D printer. As you can see, there's more pieces going on, but those are the major ones, and they're fairly consistent across printers. This is a close-up of the hot end. So you see the filament here, then the filament goes in, it gets heated up, This is the motor that's moving the hot end around, and then it comes out through this nozzle. And this gets very hot, so when you're working with the printer, be very careful. You want to make sure you do not touch that because it is very hot in temperature. So why is 3D printing important to rehabilitation? So 3D printing lets you do a couple of different things. It lets you personalize things. You could print things that are particularly complex. So sometimes, if, for example, if we're working with something similar like thermoplastic that we use to create splints, we can create somewhat complex designs, but the computer is able to print something even more complex than what we can do with our hands. It's also sustainable. A lot of the plastics can be melted after they're done and reprinted. They're also recyclable. 3D printing also is low cost. So a whole spool of filament might cost 20 bucks, and anything like a small object, maybe something the size of a stapler, would cost like maybe $1 or $2 worth of filament, depending on how thick the plastic is inside. And then there's also a shorter production time. So most things could be printed in just a couple of hours. So those are some of the advantages to 3D printing. So why are we talking about 3D printing now? So 3D printing is becoming cheaper and easier to use, which means we as rehabilitation professionals have more ability to incorporate this technology into regular practice. So the technology is not there yet, but it's important that we create the evidence now, so that way when the technology is better, which it should be in the next couple of years, then we'll have the evidence to support us in using these interventions. So now let's talk about identifying materials. So we're going to talk about the 3D printer, the filament, the things to print, and a little bit about wherewithal. So the 3D printer. So there are different options for 3D printers. You can buy a 3D printer. You can use a 3D printer at the library, or there are online printing services. So if you have the funds to buy a 3D printer, you can get a 3D printer for as inexpensive as $200 to $300. So those are going to be smaller, lower end printers, or you can get a top of the line printer, which can be extremely expensive. The printer that I print on, which you'll learn more about, is about $1,000 and is closer to the lower end of the spectrum. If you're not doing a lot of 3D printing, a lot of universities and public libraries have 3D printers where you can go and work with the librarian to print your object. If you do not have a 3D printer in your neighborhood, there's also online printer services. So you can create a 3D object, you can send the file to one of these online printing services, and then they will mail you your 3D printed device to your house. So when you are looking at different 3D printers, you should consider cost, speed, the size of the machine. And when you think about the size of the machine, think about the size of the machine overall and the print bed and the technical skills and need for support relative to how technically savvy you are. So there are a variety of 3D printers available. This is a screenshot from PC Magazine and their best 3D printers of 2017. So as you can see, these are some of the printers, and these are the ones that they recommend. So my printer is the Lulzbot Mini here, so you can see the difference in price. So you can get a XYZ Printing DaVinci Mini or a Flash Forge for about $200 to $400, and then there are super expensive ones like the MakerBot Replicator Plus and the MakerBot Replicator 3D printer, which are a little bit more expensive. So you can see here that while the pictures are the same size, each of these printers are different sizes. So there's the size of the printer, which you can see here is it could be fairly big. So you see in my 3D printer, the black outline, that's all the 3D printer, and then there's the print bed. So you could really only print things as large as your print bed. So this print bed is so the printer itself is about 15 inches by 17 inches by 13 inches, but the print bed is only 6 by 6 inches. So when you're thinking about where you're going to store the machine, you want to think about the total dimensions, but when you're thinking about what you plan on printing, you need to think about the size. So I really can't print anything bigger than 6 inches by 6 inches because that's the size of the print bed. If I were planning on printing larger things, then I would have to invest in a larger 3D printer. The other option is to print several smaller things and combine them together, but whenever you combine things, they tend to have more potential to break than if you printed them as a solid object. So something to consider. They also print at different speeds. So this printer only has one head, so it extrudes one line of plastic at a time, but some of these other printers have two heads, and so they could print twice as fast. And so when you're thinking about how long you have to engage in printing, you might look at the print speed, because it can cut it down. And sometimes if you're going to print very complicated designs, then you need two heads, one to print what you're printing and then one to print some support to help the objects stay up. So if you're going to print some really complicated, intricate designs, you might also need a more advanced printer. So I'll walk you through what I was thinking when I purchased my printer. So I got the Lulzbot mini printer. It was priced about $1,000, which was in my budget. And so some of the pros is that it's really easy to use. It's high resolution. It works with a variety of filaments. It works on a variety of computers. And when they tested it, they didn't have any misprints. So a misprint is when you go to print something and then it doesn't come out and they have to throw it away and try again. And it was easy to use. So the things they didn't like about it was that it was inconsistent in quality. So there might be like a blemish. It's also open. So as you can see in the picture, there's no glass enclosure. So you can see the MakerBot is enclosed. So when it's enclosed, it helps with the smell. It's also a little bit safer in case there are a lot of people who walk by the 3D printer. You don't want them accidentally touching something. But overall, they thought that it was easy to use, easy to set up, and consistent. And so as a novice, when I first started using this 3D printer, I wanted something that was easy to use and had consistently good prints, and it was the right size for me. So it was the size that I could store this in my lab, and I wasn't going to be printing anything too big, so the size of the print bed was not a problem. And so that is how I ended up with the Lulzbot mini 3D printer. So filament is what you print. So most often we print in thermoplastics. We print in thermoplastics because they are fairly cheap and they're available in a variety of colors. So there are different types of thermoplastics. So one is PLA. So the advantage of printing in PLA is that it's environmentally friendly. It's made from plant sugar. It does biodegrade over time. So if you need to print something that's going to be consistent and available for years and years, this might not be the best plastic to print in, but it is safe for food. But it does degrade, so it's not great for medical implants. When you feel this plastic, it's brittle and it biodegrades and it has a low melting temperature. So I live in Miami, so I don't often use this plastic because it gets so hot in cars and pretty much everywhere around Miami. I was very concerned about the low melting temperature. So I don't typically print in PLA, but it is a very common plastic to print in. The next thermoplastic filament is called ABS, and this is the type of plastic that is used to make Legos. So this is nice because it gives you a nice smooth print. So it gives you a higher quality with a nicer look and feel. It's also stronger and more flexible and durable. but the cons are the odor and the fumes, and it's also oil-based. So when you're printing, you might notice an unpleasant smell. So if you're working in close proximity, you're not going to necessarily enjoy being in the same room as the printer. The plastic I print the most often in I call HIPS. And so this is used in packing materials and food containers. So if you've ever used disposable utensils like plastic forks and knives, those are most often made out of HIPS. It's very similar to ABS. It is durable and has a high melting temperature, which is one of the reasons why I selected this plastic, and it's dissolvable. So as I was talking about earlier, sometimes you need two print heads to print a complicated design. And so as you see in this image on the right, they wanted to print this cat, but the cat wasn't necessarily standing on its own and needed a little bit more support. And so what they did is they printed it on a printer with two heads, and the blue is material is what they wanted to keep, and the white material is just support material. And so basically what happens is the blue material is not HIPS, it's a different material, and the white material is HIPS, and they take the device after it's done printing, immerse it in a chemical, and then the white material goes away, leaving you with this beautiful print. The con is it's brittle, so it doesn't give you that nice texture that other plastics do, and it does also biodegrade over time. And as I mentioned at the beginning, you could print in a variety of materials. So you could print in wood, metal, sand, concrete, cloth, even food. So this is an image of a 3D printer printing in pancake batter. So know that while most of the time we print with plastic, you could print in anything. You just have to make sure that whatever you're printing in is consistent with your 3D printer's manufacturer's guidelines. So we talked about the printers, we talked about what you print with being the filament, and now you just need something to print. So you can print anything on a 3D printer. You could get objects from an online repository. You can get an object from an online repository that you edit or adapt. You can design something on your own, or you can scan something on your environment, and print it. So you can download an object from an online repository. So you know how when you are creating a Microsoft Word document, when you save it, you go and you look at that file. At the end of the file, you'll see .doc or .docx. When you have a file for 3D printing, oftentimes you'll see a .stl or a .obj, and that will denote that it's a three-dimensional object that can be used for printing. The most popular repository that I found is called Thingiverse. So you see the link at the bottom, thingiverse.com. They have a variety of objects that you can 3D print. So you go on, you search for what you're looking for in the search term, and then you download the object. There's also, and so Thingiverse has a variety of things. It has assistive technologies, it has toys, it has tools for teachers. Pretty much it has the biggest variety. The NIH 3D Print Exchange has a lot of science figures, so it provides models related to research going on from NIH-funded researchers. There's also E. So this is a fossil that was found in Africa, and they scanned all of her bones and put them online, so you can download her set of bones and print them out. You can also scan an item, so I also have a structure sensor. So it is an attachment to an iPad. You connect it to an iPad. You see the device right there. So you walk around the object and you scan it just like you might scan a paper document. You scan a three-dimensional object, and then that will give you a three-dimensional object file that you can print. And so I scanned with help, someone scanned my head. So I used the structure sensor, and basically it took lots and lots of pictures of my head in different from different perspectives, and from there it created a 3D object file. And then on the right you can see a three-dimensional model of my shoulders and head. There's also Imba 3D, which also has a lot of medical models. So if you are working and you want to study anatomy and physiology, this is a great spot, and it can also convert medical images into three-dimensional files. So say you get a hip replacement, you get a copy of your hip, you can use Imba 3D to print out a version of your hip. And then you can also draw your own. So this is called computer-aided design, or CAD software. There are a ton of different CAD softwares available. AutoCAD and SketchUp are two popular options, but think about using Microsoft Paint or in Microsoft PowerPoint when you create your own designs by combining like circles and squares and changing colors and changing shapes. You can put your own designs together to make whatever you want. So maybe you go to a repository, you don't find what you want, and you know you need to create it yourself. Then you could draw it your own using a computer-aided design. My favorite computer-aided design software to use is called Tinkercad. It is online, so you don't even have to download anything onto your computer, and it's free. So they have a series of tutorials that allow you to learn different skills in Tinkercad, and then it has a great user interface that you can use to create whatever you need. The other thing you could do with Tinkercad is maybe you find an object that you like on Thingiverse, but it's not 100% right and you need to tweak it a little bit. Often you can take the object from Thingiverse, bring it into Tinkercad, and edit it just a little bit or whatever you need. So you can make something taller, you could make something wider, you could put words on top. You could do whatever you need to make a device that's going to work for you or for whoever you're printing the device for. So in this presentation, we talked about the different equipment that you use for 3D printing. We talked about looking at the different materials and how you pick materials, and then we walked through the process. In the next video, we will look at a more hands-on example of creating a 3D printed object. Thank you for your time and attention.